Hi guys, so last time we talked about Spark pools inside Azure Synapse Analytics, feature of Synapse that you can use instead of Azure Databricks. And it works. We were able to run our replicable transformations processing inside this. Now, what I would like to cover today are some additional capabilities of Spark pools, like integration with other Azure services. And that's the topic for today. So let's get started. Alright, so let's talk about how Synapse, Spark pools inside Synapse, integrate with other services in Azure. And let me start with data integrations. So let's jump into Azure portal and let's take a look at our Synapse Studio. So that's my workspace, and here under Data tab, you should remember that we have this linked tab that displays various linked services that we have configured within our workspace. And what I did last time was to simply go to my ADLS Gen 2 linked service. That's the data lake that contains our data, this stuff read from replicable. And what I did was to right click on one of those files, those JSON files, like replicable minifix JSON, and then use load to data frame option. That resulted in generation of this code that is used to simply read data from this particular file using PySpark and then display it. So let me run this on my demo pool. And now it will take a few minutes for the pool to start, so I will be back in a second. Alright, so my Spark pool has started. It took 3 minutes for Synapse to make it done, and you can see that somehow Synapse Spark pool was able to connect to my table data lake and retrieve the data. But how it was able to connect? Will it work with any other data lake that we'll have in our environment? And actually, let's test this. So what I created in the meantime was this additional data lake called, additional data lake table. It is really a data lake. And when it comes to permissions, what I did was to grant storage blob data contributor role. So this is this data plane role to managed identity of my Synapse workspace. And pay attention here. You should remember that Synapse has multiple features under the hood, like pipelines and Spark pools and some other sub-services as well. But still, it uses a single managed identity. And it will use the same identity no matter from which component you will try to access some other service. So it means that here I just configured access for my managed identity of my Synapse, and it would work regardless whether I would like to call it from pipelines or from Spark pools, but we'll get back to it in a second. Please also note that me, Piotr, I have only the owner permissions. I don't have those data plane permissions, and that will be important in a second. Alright, so what we would have to do in Synapse to have this new data lake visible here under linked would be to simply create a new linked service. And actually I could go to manage tab and then to linked services, or use this shortcut, this plus sign from this data tab, and let's use it. So let's use connect to external data, and in this case this additional data lake is treated as external to Synapse. So let's do this. And here, compared to this linked service UI, we've got a limited number of services we can connect to. But this is fine, because we want to connect to a data lake, and it is available here. So let's choose our data lake. Let me call it like additional data lake linked service. Let's use system assigned managed identity as an authentication type. So it means that I would like to connect to this data lake using managed identity of my Synapse workspace. And finally, let me indicate that yes, I want to connect to this additional data lake table data lake, and let's verify connectivity. And it should work because, as I showed you, this managed identity has storage blob data contributor role granted. And it was indeed successful. So let me create this. Let me publish this linked service, so it will be available later on. And let's see what will happen if we will try to follow the same steps as previously, but with this data lake. I mean, just right-click on some file and then try to load it to our notebook. And before we do this, let me show you what I have in this data lake. So I have a single container called row, inside which I have a test directory, and then I've got some free files. This minifix, JSON, sample JSON, and some XML file. This XML file will not be important today. We'll focus just on those two JSON ones. Alright, so let's get back to our workspace. Here, if I refresh my linked data sources, I should see this new additional data lake ls linked service available, because we just created this. And if I try to browse it, yes, I can see my raw container. I can see this test directory, and let's try to load this code. And actually, let me copy this into the previous notebook, because here I have my session already up and running, so we wouldn't have to wait for it. So let's try to do exactly the same as previously. So this code, it worked, and it connected to my table data lake demo. That's my main data lake. And basically the same code was generated for my additional data lake table. And let's see what will happen in this case. And take a look. It failed. It failed with error that access denied. This request is not authorized to perform this operation using this permission. But why? Why it worked previously for another data lake, but here it doesn't? And the answer is the way Synapse Spark Pool connect to external sources. So it is like this. If we are connecting, if we are running our notebook in an interactive way, like I'm doing right now, just by clicking and running it manually, it will use an identity of a user executing this notebook. So in this case, it was my identity. And because me, as Piotr, I don't have those data plane permissions, we can verify my permissions on this data lake, and I have only owner and user access administrator roles. That's why I wasn't able to display this data. Or to be more specific, Synapse Spark Pool was not able to display this data. And actually, let me start drawing this, how it looks like. So it is like this. So we've got our Synapse environment, and it looks something like this. So this is Synapse. Inside Synapse, what we did was to write our notebook. So this time, this icon, it represents our notebook. Notebook that tried to connect to some data lake. So we've got a data lake below. So this is ADLS Gen 2. And the thing is like this. So connectivity was in this direction. From notebook, we tried to connect to a data lake. And now the first case is this interactive authoring. So let me draw it like this. So interactive. So in this case, it was me connecting to this notebook using Synapse Studio UI, and then executing it manually. And in this case, simply Synapse will use identity of this user. So it is something similar to what we had in Databricks. It was called their AAD credentials pass-through. Here it is called pretty much the same. It is called Entra pass-through because AAD was renamed to Entra. So Entra pass-through. Like so. Which means that, hey, this notebook, well, it used permissions of me. And because I wasn't granted sufficient permissions to read data, that's why it failed. Simple, right? And now, you might be wondering why I'm covering security so much to that extent. Is it really necessary for the exam? And the answer is kind of. Even if it is not necessary for the exam, then obviously you should know at least the basics of security stuff to be able to secure your data. And secondly, as a data engineer, you will be connecting to various places. And sometimes this connectivity will not work. And you should be able to perform some basic troubleshooting what is happening. So you should understand at least some basics of this process. Alright, so it means that in the case of this interactive development, Synapse used mine permissions, which also means that it might be a little tricky because me, as a developer, maybe I have permissions granted on the data lake, and I developed a code, I tested this, and it worked. But later on, my colleague would try to modify this notebook, and maybe it will not work for him because he is not granted the access. Which means that maybe running this connection in the context of a user is not the best thing to do. Maybe we would like to make it work no matter of a developer who is interacting with the notebook. And the solution to make it work is to simply use a managed identity of our Synapse workspace. And we saw that we have this workspace. So let me show you how it could be done. So let's jump back to Azure Portal and to our Synapse workspace. So this code, well, it failed. It failed because I didn't have permissions. On the other hand, managed identity of Synapse, so this one, it has storage blob data contributor role. So I would like to run the code of this notebook using managed identity of Synapse. So how can we do this? And the answer is simple. Let's go back to our notebook. And here in the corner, we've got this gear that allows us to set various properties of our session. And here at the bottom, you will see this option run as managed identity, which means that if I set this, then the execution of this code, of this notebook, will no longer use my identity, but instead will switch to identity of a Synapse. So let's apply, and it will restart my session because it has to make some changes in it, but that's fine. And please note that here we've got this small tooltip that says using managed identity. So it should give us a hint that from now on, this notebook will connect as Synapse workspace identity, not as the identity of a user running the code, which is exactly what we wanted to do. So let's try to rerun the same code that failed previously and see if it will work this time. So let's run this. And again, let's wait a second for Synapse to start the session and then to execute the code. And take a look, it worked. The data was returned. And apparently I can see that we have different versions of our minifix JSON files stored in both data lakes because data looks a little bit different. The second file is simply smaller, but that's fine. The goal of this exercise was to show you that you can force using managed identity of Synapse Workspace to connect. So actually, let us update our diagram that even in case of interactive development, we can switch from enter pass-through to managed identity. Managed identity. And actually, this option of using managed identity is quite useful, especially when you want to debug something, because later on you will see that in some other cases, Synapse will use managed identity to connect. But we will see this in a second. All right, so let me disable this managed identity stuff for now, because I want to show you one additional method. Namely, well, we configured linked services already, right? And a linked service is simply a connection string to our resource, in our case to our data lakes. And inside those linked services, we already defined the way we want to connect to them. So couldn't we just reuse this linked service configuration instead of using some default method? And the answer is yes, you can do this. And actually, that's a super cool feature of Synapse, that once we defined a linked service, then we can use it in multiple places, like in pipelines and here in notebooks, in Spark pools. So let me add a new cell. Let me just find the place where I can add a new code. And I will copy a code that was grabbed from documentation. And it will be something like this. And let me explain what it does. So first of all, yes, it will be a PySpark code. Then let me define a variable that will store a name of a data lake to which I want to connect. In my case, it is this additional data lake table. That's fine. Then I have to set some configuration of my Spark session, which will tell Synapse that, hey, whenever I want to connect to this additional table data lake, then please connect using a linked service that is named like this. And actually, I think I have the name set a little bit differently. So let me grab the name and let me update this. So the name of my linked service is like this, additional data lake ls. And then finally, let's set one additional feature that in case of using this linked service that we know uses managed identity under the hood, we have to use this linked service-based token provider library, whatever that is. It is simply taken from documentation. All right, and then we're just going to read data from my additional data lake table and display the results. And previously, actually, let me show you that it doesn't work. So that's the code. That shouldn't work this time. This one, because I disabled this managed identity configuration. So again, Synapse Spark pool will try to connect using my identity and will try to use my permissions. And because I don't have permissions, it will fail. But the same code with additional configuration, like here, it should work, because here we will tell Synapse explicitly to use our linked service for connectivity purposes. So let's wait a bit for the Spark session to start, and then we will see the results. All right, so the first execution failed as expected. So let's now try to run the code which has this explicit usage of linked service defined, and hopefully it will work. And actually it didn't, so let me stop the session just to clear everything. And to stop the session, I use this stop button. So yes, please stop the session. And let's run it one more time. Let's create a brand new session, which will use this setup from the very beginning. And let me back in a second. And take a note. This time it worked. We got the results back. I didn't use explicitly a managed identity that was configured at the session scope. No, it worked because I used a linked service. And because this linked service was using a managed identity and it was granted sufficient permissions, that's why it worked. So that's yet another method we could use to connect to our data. So let me add it to our diagram. That we have yet another option of using linked services or linked service. All right, great. So we have those three options. Let me now stop the session, and actually I will create a brand new notebook that uses this code. And I will create a brand new notebook because I would like to show you how you can integrate execution of notebooks with our pipelines, because usually that's what we want to have, right? Our pipelines would be used to orchestrate the whole process and maybe to ingest the data. And one of the steps we would like to run would be to simply run our notebooks that do something like transform our data. So let me create a new notebook. Let me call it get data from ADLS Gen 2. All right, and let me paste the code. And that's the code that connects to my additional data lake. And in this form, it should fail. Because again, it will be executed using my permissions. And we know that I'm still not granted access to this data. But that's fine, because I want to show you a different behavior when this code will be run in a non-interactive way, like from pipelines. So let's wait for this cell to fail, and then I will show you how to make it work. All right, so this code failed as expected due to lack of permissions, but let's now ignore this error and let's try to incorporate execution of this notebook into our pipeline. And it is super simple because here in the UI we've got this add to pipeline button. Actually it is called, add to pipeline. And if I click on this, I can choose whether I want to add execution of this particular notebook to a new pipeline or to an existing pipeline. And I will choose new pipeline because I think I don't have any pipelines that would work pretty well here. So yes, please create a new pipeline and let's call it integration with Spark Pulse notebooks. And take a look what happened. Basically, what was added automatically was this new activity called notebook. And you can find it here in the menu under Synapse group. And it is simply used to execute some notebook from our Synapse workspace. And it was automatically pre-configured to indicate that we want to run our get data from ADLS Gen 2 notebook. And please note that here we don't have any linked service to be configured because, well, notebook and pipeline, they exist in the same Synapse workspace. So Synapse knows that it will be the same workspace. So there's no point in setting a linked service. What we just have to do is to indicate which notebook we want to execute. But because we did this from the context of our notebook, this property was set automatically. What we have to do then is to indicate, alright, which Spark pool we want to use to execute this code. And in our case, it was this demo pool, I believe. And that's it. So let's run this. Let me debug this notebook and we will see if it will work. You should remember that when we run this interactively from notebook, it failed due to not sufficient permissions. But will it be different here when I run exactly the same notebook, but from pipeline? We'll see. So let's wait a second, and I'll be back when it's finished. All right, and take a look. I don't see any errors on my notebook execution. So let's see. Let's take a look into details. So let's click on this glasses icon, the same stuff as in Data Factory pipelines. And actually it worked. Data was returned. Data was read this time. So how is it possible that when I was running it manually, it failed, but when it was executed from pipelines, it succeeded? And it was exactly the same notebook. We didn't change anything in the meantime. And the answer is, well, let's jump back to our diagram. So the first case, the interactive development, is on the left-hand side. But what we did this time, recently, was to run it in a non-interactive way. Non-interactive. In our case, we executed this notebook from our pipeline. So this is a pipeline. And there was this notebook execution task that simply executed our notebook. And in this case, in case of those non-interactive runs, it behaves differently, because in this case, it uses managed identity of Synapse. So that's pretty important. So here, it uses managed identity. Which might lead to some errors. So imagine a case when you are developing your code, like we did in our Spark notebook, and if you didn't configure any connectivity, then by default it will use your permissions, because it will run using these Entra pass-through options. And if you are granted permissions, then from your point of view, everything will be fine. But then once you deploy it to some prod environment, and then it will be executed using a managed identity of Synapse, it might fail, especially if you forget to grant those permissions. So that's this nasty surprise that might happen if you don't know how it works. So what I suggest to do is to use one of two options. So either develop your code in notebooks using this managed identity option from the very beginning. That's possible. So it was here. Use this. Or simply don't rely on this default behavior and configure it from the very beginning using some linked service. So it will always work in the same case. All right. But what I will do right now, because I want to develop the code, so I will switch to managed identity, because I want to be able to run this and to test it that it really works. Because because me as Piotr, I don't have permissions, then obviously it will not work if I don't switch to managed identity. So let me verify that it works, and again it will take ready. Alright, and now additional file, this sample JSON.json file that I have in my additional data lake. So let me use this preview functionality. Alright, so we can see it is a very simple JSON, smallest possible JSON. And actually what I would like to do would be to modify my notebook and to load it, just to verify that it can be properly loaded. And the file name, it was called sample.json, if I recall correctly. So let's try to run this. Alright, and it worked, right? Great. Now, let's imagine that actually I would like to reuse this pipeline and sometimes use it to load the contents of sample.json, but sometimes I would like to load our minifix and then do something with this. And furthermore, I would like to still run it from my pipeline, which means that, well, I should parameterize my notebook to be able to pass a name of a file I want to read. And you should remember that in case of Databricks, what we had were those widgets, those parameters that were explicitly defined, which allowed us, well, to pass some parameters. Here in Synapse, it is done in a different way. Which one is better? Well, from my point of view, it's a Databricks way, but decide on your own. So what I will do would be to add a new cell with a variable. Let's call it file name. Let's set it by default to sample.json, and let's use it in our second cell. So I will just use this ugly concatenation that please, when executing this second cell, then instead of this file name placeholder, use a value that is set in the first cell. So let me verify that it works. And I will run my whole notebook at once, so cell after cell. And it should work with sample.json. It works. And it also should work with minifix. So let's run this. All right, and it worked. Great. So how to make this file name variable a parameter? And well, we don't have widgets here. If you try to find something like add a parameter, add a widget, no, you will not find it. What Synapse decided to do was to have this, have this toggle parameter cell option. So let me click this on my first cell that contains this file name variable. And what it did was to add this small command called parameters on my first cell. And what it does effectively is that every variable that is defined in a cell marked as parameter will become a parameter to this notebook. And then we'll be able to use those parameters when calling the notebook, like from Data Factory, from pipelines, not Data Factory. So let's go to our pipelines and let's add a parameter. And it was called a file name. File name, I believe. Yeah, file name. And let's set it to a string type. And let's give it a value of sample.json. And let's run this. And let's see if this value will be passed to my notebook and what changes it made inside the notebook during the execution time. So let's wait a second. All right, so the notebook has been executed. It succeeded. So let's see how the execution would look like. And take a note that this was our original cell with a minifix value set as a default value for a file name variable. But what Synapse did was to add automatically additional cell just below this cell that was marked as parameters. And what it did was to set value of every variable to values provided from pipelines. So in our case, it set file name to sample.json. And this way it was able to override those default values set in the original cell. Not too intuitive, in my opinion, but hey, that's how they decided to make it. And the execution worked without any issues. It really used my sample.json value that we passed from pipelines. And yes, that's the content of my file. The same will be if we change our parameter from sample.json to minifix. So let's just double check that it really works. So let me run this one more time, but with a different parameter. This time it should also work, but we should read this minifix.json file. Alright, and it succeeded. So let's jump into details. And this time we should see that yes, our parameter was set to minifix value. And this time we got a different content of the minifix file. So that's how you can parameterize your notebook and pass parameters from pipelines. So this is a different way compared to Databricks. Alright, so what we saw was that we can run our Synapse notebooks from Synapse pipelines. That's pretty obvious. It would be really bad if those two components of Synapse weren't able to talk to each other. So actually, let me draw it. So let's say that this is a Synapse notebook. And we also have Synapse workspace or Synapse pipeline, from which we execute our code. So this is a Synapse pipeline. And we know that yes, this way is possible. We can run a Synapse notebook from Synapse pipeline. And actually, it was pretty similar in case of Databricks notebooks and Data Factory pipelines. We saw in previous episodes that this is possible. So let me draw it. So this is Databricks notebook. And we also had Data Factory. So this is Azure Data Factory. And we know that this connectivity works, or execution works. Alright, but how about calling a Databricks notebook from Synapse pipeline? Or calling a Synapse notebook from Data Factory? Is it possible? Let's check. So let me jump into our pipelines in Synapse. So this is an activity to call notebook from Synapse. Fine, that works. But what we also have is a possibility to call a Databricks notebook. It wasn't possible from the day one, but now we have it. And obviously here you would have to create a linked service to Databricks, because Databricks is a different service than Synapse, and we have to indicate which Databricks we want to connect to. But this is possible. So if for some reason you would like to use Synapse pipelines for orchestrating purposes, but use Databricks for transformations, it is possible if you need to do this. Which means that calling Databricks notebooks from Synapse pipelines is possible. So this path works. So how about this one from Data Factory calling Synapse notebooks? So let's verify this. So I'm in a Data Factory and let's open some pipeline. This one is fine. It has some activities, but that's not important. And here, yes, we've got this Synapse stuff that we could use, this notebook activity. And here, obviously, we would have to again use a linked service to Synapse Analytics, because Data Factory is a separate service compared to Synapse. If you were to run a notebook within Synapse pipeline, like we did here, we don't have this linked service because it is not needed. But in general, this connectivity, this path of execution works. So we can mix those four features however we want. It is supported. But the question is, do we really want to mix it? And if yes, then why? So you should double think if that's what you really want to do. Alright, so let's move on. The next thing I would like to show you is again integration of our Spark notebooks with other Azure services. This time, let's think about Key Vault. In Databricks, it was possible, and to be able to read a secret from a Key Vault, what we had to do in Databricks was to create this secret scope. Yeah, secret scope that was configured with a specific Key Vault using this hidden UI URL. In Synapse, it is done simpler because what we have to do is to simply create a linked service. And actually, to be honest, a linked service is not required. We could try to read a secret from a Key Vault without a linked service, but then it would use an identity of a user running the code, which might result in a nasty surprise in production if permissions are not granted. So what is the recommended way? Is to create a linked service to a Key Vault and use a managed identity of Synapse. So let's do this. So I have my demo Key Vault table, that's my Key Vault, to which I would like to create a linked service inside Synapse. So let me go to linked services and let's add a new Key Vault linked service. Azure Key Vault linked service. Let's use this dummy name. Let's indicate which Key Vault we have in mind. It was this demo Key Vault table. Then let's make sure that it will use system assigned managed identity to connect. Yes. And will it work? Yeah, it worked. Let me publish all of this stuff. And let's verify permissions on a Key Vault. Here, this Key Vault has an access policy defined that granted get and list secret permissions on this demo Key Vault secret reader group. And if I recall correctly, managed identity of our Synapse workspace is already a member of this group because we needed this when we were playing around with this replicable data ingestion. But let's verify. So let's go to Entra, to this demo Key Vault secret reader group, and let's verify who is a member of this group. And yes, our Synapse workspace managed identity is a member of this group, which means that Synapse should be able to get and list secrets. Alright, so how to make it work? And did I publish this? Alright, there are some errors. That's fine. Let's ignore it for now. Maybe it will work without publishing the link service. So let's go back to my notebook and let's add a code. And again, that's the code that was copied from documentation that tells us how we can use a linked service to get a secret from a Key Vault. So yes, please add a new cell. And what I'm doing here, actually, I would like to disable this managed identity. So please disable this. And what this code is doing. So I'm using this MS Spark Utils package, then the method called getSecret, and we've got to configure it. So first of all, we've got to provide a name of a Key Vault to which we want to connect. In my case, it is demo Key Vault table. So let me fix this. Then we've got to provide a name of a secret which we want to retrieve. And actually, we didn't create any secret yet. So let's add a new one. So let's call it Synapse secret. And let's give it some value. Alright. So secret has been created. Then in the middle, we've got to provide a name of the secret, and it was Synapse secret. And finally, we've got to indicate which linked service should be used to connect to this particular Key Vault. And in our case, it was this Azure Key Vault linked service. And actually, I think the name is fine. So let's try to run this. It might fail because this linked service is not yet published, but we'll see. So let's try to execute this code. All right, and it failed. And it failed because of what? Could not find linked service. Yeah, basically this linked service is not yet published, so we have to publish it before we can use them. And I recall there were some errors with publishing, so let me disregard all of this stuff that we don't need. This notebook free, let's forget about this, and let's publish it right now. And previously publishing failed because there were some errors in the configuration of the pipeline. I believe in this Databricks notebook execution step. Some mandatory properties were not set, and that's why we were not able to publish this. And please note that here in my Synapse workspace, I'm working this Synapse live environment, which means that when I'm clicking publish, I'm deploying the stuff directly to the service. Similar concept like in the case of Data Factory. And obviously a better way would be to configure code repository here and work it in a more mature way. But for test purposes, that's fine. Anyway, this Key Vault link service has been published, has been deployed, so this time we should be able to use it. So let's see if this time I will be able to connect. And yes, it succeeded. And when I tried to print a value of my secret, it resulted this redacted statement, because it knows that, hey, this is a secret, and probably I don't want to show its value just like this. But the key point here is that retrieval of this secret worked by using this linked service. Now, please remember that this redacted thing, it is not a security measure. It is very easy to be able to read a value of our secret, and the same applies to Databricks. One of the common methods is to simply iterate over this S variable, like so. So I will be doing a loop character by character and then printing each of them. And this will be enough to display a value of my secret, which indeed was set to my super secret value. So the key point here is that connectivity works, and that's the recommended way. If you need to get data from a Key Vault, from Spark notebooks, well, simply create a linked service and connect to your Key Vault using a linked service. Alright, and one more thing that I would like to show you today is about data partitioning. And that's the concept that is global. I mean, it is not related only to Synapse. It is more of a Spark thing. So basically, you should remember that we use Spark when we've got a lot of data, huge amounts of data. And one of the optimization techniques that was used in the past and nowadays still is to distribute our data into multiple directories, into multiple folders. Because let me show you how the data looks like at this moment. So let's go to my table data lake demo. That's our main data lake that contains transformed data. So in our curated directory, we've got, let's say, this minifix Synapse. So that's the data about our minifix, saved as delta. But please note that it was saved as to Parquet files. Alright, maybe that's fine, but let's imagine that we've got a huge amount of data. Really, big data. And maybe we would like to distribute it to multiple folders. So later on, Spark would know which files it has to read to fulfill some criteria. And that is called partitioning. So what I will do here is to simply do like this. So I will explain the code in a second. Oh, come on. All right, so what we have right now is in our data tab, we created previously this Piotr minifix data. So that's our table that contains transformed data. And actually, let's see what is inside. So let me copy this statement. Let's add a SQL syntax. And let's take a look into our minifix table. That is physically stored, if I recall correctly, here in this directory. And please run the code and let's show us the content of our minifix data. Alright, so that's our transformed data and it looks pretty good. And let's assume that we've got billions of rows and we would like to split them somehow, distribute them somehow on our storage layer. And maybe we would like to split it by this last modified date in a way that we would like to partition it by year and month of last modification date. That's just one of the examples. And maybe we want to do this because we know that we've got a lot of queries that later on filter data based on this last modified date. So if we split it properly, then Spark will know which files it has to read and which ones it doesn't have to read, which will make the whole processing faster. So what I'm doing in this cell is to simply import some functions, those two, to be able to calculate year and month of a date. I'm creating a new data frame that simply gets the content of my table, and then I'm adding a new columns, year and month, that contain only this part of our last modified date. And let me show you how it looks like. Alright, and those new columns are added at the end. So these are our two new columns. And what I would like to do is to save this data on our data lake, but this time partition it first on a year and then on a month. And let me do this. So again, I will just copy the code that I have created. Let me remove those unnecessary tabs and let me explain the code. So I'm using our data frame that contains those year and month columns. Then I'm writing it somewhere. Important step is I am telling Spark, please partition this data first by year column and then by month column. And then simply use delta format when you are saving the data to a data lake. Then please save it to this minifix Synapse partitioned directory. And also please register this as a table in our catalog. So let's run this. And let's see how the data will look like on our data lake, what changed, just by using these partitioning features. And actually, last week a new feature was released from Databricks that was called liquid clustering that might make this old partitioning style that I'm showing you right now, it might make it obsolete. The partitioning I'm showing you right now, it is called Hive partitioning. And Databricks says, hey, with this new feature called liquid clustering, you will no longer have to bother with your manual partitioning because we got it covered. We will see if this will work, but for sure you will find systems in which this old partitioning method is still being used. Alright, so first of all, this cell succeeded, so let me refresh our catalog, and we have this new table called minifix synapse partitioned. So nothing changed here, and we can obviously use this data and query it in the same way as any other table. So it will still work. It is still a data that is available for further processing. Yeah, it is available. But what is changed is the way it was saved to a data lake. So previously we had two files in our main directory, but when we partitioned this in this directory, what happened was that those directories, intermediate ones, were automatically created, and they follow the pattern partitioning column equals value. For example, in this case, year equals 2020, year equals 2021, and so on. And then within each directory, we've got yet another level of data partitioning, this time by month. And if we go even further, then we'll have finally our data files. And because this SparkF file is stored in this year equals 2020 and month equal to 10 directory, we know that this file will contain only those rows which last modified date meets this criteria. So if we write our query in a way that it checks for rows that were modified in 2020 in October, then Spark would know that it has to read only this single partition, only this single file, which makes processing faster. So that's how we can have this data partitioning done in this old style Hive partitioning way. That maybe is obsolete, maybe not, we'll see. Now, and that's basically it, what I wanted to cover about Synapse Spark Pulse. We'll revisit this topic when we'll be exploring some additional capabilities or components of Synapse, and we'll discuss how they work with Spark Pulse. But for now, that's enough. So let me summarize this. So we can use Spark Pulse in Synapse, well, to transform your data. That's the main goal, I would say. And if you were to position this component in your architecture diagram, it would be placed in the same place where we had previously Azure Databricks. So you can use this one or this one, it's up to you. Both of them use Spark under the hood. And it's actually up to you to decide which one works better in your case. If you have existing project that is using Synapse, then probably I would keep using Synapse and Spark Pulse for this purpose, for transformations. If I were to start a new project, probably I would move away from Synapse. But again, it's up to you. So that's it for today. Thanks for watching and see you next time. Take care.